Everybody ready?
Wait.
You ready? Okay. You gonna keep notes?
You ready to
Okay.
keep notes?
Okay.
Wait.
All right. And go. Okay. So talking about the kidney here. Okay. So the kidney is found in the retroperitoneal space, meaning it is not in the abdominal cavity. It's in between the abdominal cavity and the ribs. So it's in its kind of its own little pocket there, and it's covered by large amounts of connective tissue to keep it from moving it around. You've got the renal artery. So blood is going to come in from the renal artery. It's going to go into the interlobar, arcuate, interlobular arteries of the medulla, and then it's going to go into the cortex. And from there, it's going to go into the afferent arteriole. Blood will come in the afferent arteriole, and then from the afferent arteriole, it'll go into the glomerulus, which means ball of yarn. On the glomerulus, there's these things called podocytes. So remember, literally just like the mesh screen on the cheesecloth. So it filters out. Everything that can be filtered out will be filtered out into the Bowman's capsule. From the Bowman's capsule, it'll go into the PCT, the proximal convoluted tubule. From the proximal convoluted tubule, it will go into the descending loop of Henle, the ascending loop of Henle, and then into the DCT, the distal convoluted tubule. And from the distal convoluted tubule, it will go into the collecting duct. Okay? Like we talked about in lecture and Hank talked about last week, initially everything goes out of the bloodstream and into the Bowman's capsule. Okay? So then we selectively reabsorb. Some of it gets selectively reabsorbed in the PCT. Some of it gets selectively reabsorbed in the descending and ascending loop of Henle. And some of it gets reabsorbed in the PCT. You can see here, you see these blood vessels. Those are called the peritubular capillaries. That's where the actual reabsorption occurs. Once it hits the collecting duct, it's gone. Except for water. Water can be retrieved from the collecting duct when our body secretes what hormone? Antidiuretic hormone. So antidiuretic hormone increases the number of what we call aquaporins, so we can reabsorb more water back into the system, right? So what's a chemical that inhibits antidiuretic hormone that humans consume? Caffeine. What's another one? We talked about this. Ethanol, otherwise known as drinking alcohol, right? So caffeine or alcohol or both will inhibit antidiuretic hormone and thus increase diuresis, okay, or urine output. That's why we call it a diuretic, because it increases diuresis. Okay. So
Sorry.
Go ahead.
No, does that, like, when you're drinking and they're like, oh, you pulled the cork?
Yep.
Because as soon as you pee that first time, you're in and out of the bathroom every 5 minutes?
It's mostly because now it's hit you. Yeah. So So it's mostly just the consumption of the alcohol. The more alcohol you consume, the more it inhibits. So what's the alcohol by volume for beer? Like even a strong beer, 9 or 10%. For a really strong beer, 10% alcohol by volume, which means it's what? 90% what by volume? Water.
Oh, water.
Right. Wine, 12 to 15% alcohol by volume. So it means it's 85% water. Really strong liquors, right? You know, a really strong liquor, you might be 50% alcohol by volume, which means it's still mostly water, right? So you're drinking a diuretic plus a lot of fluids equals lots of diuresis. Yeah. Okay. So once it hits the collecting duct, so all of this is happening inside of the cortex. Okay, so you can kind of see here, you can see a little bit of a demonstration of the collecting ducts. So the collecting ducts will go down into, so these are called the renal pyramids, for what should be fairly obvious reasons. They're pyramidal shaped. In between the pyramids, we've got the renal columns, okay? So the filtrate will go into the collecting ducts, which will then go from the cortex into the medulla. From the medulla, it will go into several minor calyces. From the minor calyces, it will go into a couple of major calyces, and then it will go from there into the pelvis, and then from the pelvis into the papillae. It's literally like a drain, right? So just like a drain in the floor, the lowest point in the kidney is the point where the ureter starts, okay? So then the urine will go from your left and your right ureter down into your bladder, okay? And as we talked about, your bladder is triangular shaped when it's empty, and it becomes kind of pear-shaped when it fills up, right? So once it gets to, so the average bladder is hold about a liter, right? So you get to about the 500 liter mark or 500 milliliter mark, you're like, I'm probably gonna have to go to the bathroom soon. Once you get about the 700 milliliter mark, you're like, okay, like I'm gonna go to the restroom. If you get all the way to 1,000, you're like, I gotta go to the bathroom like right now, okay? So then you got the two sphincters. Once so there's a thing in the bottom called the trigone, which measures pressure. Once the pressure gets high enough, the trigone will tell the internal sphincter to automatically release. Once that inner sphincter releases, like you're really trying to hold it in at this point, you really gotta go. You then voluntarily relax the external sphincter, and then a combination of gravity and pressure will cause the urine to evacuate. As we talked about, the urethra is very small in females. It's primarily just for, actually it's only just for evacuation of the bladder. In males, it's part of both the reproductive as well as the urinary system. So it's a pathway for urine as well as seminal excretions. We talked about that. So on the male reproductive system, you've got that prostate, which goes around it. So as men get older, oftentimes that prostate gets enlarged and it can actually pinch on the urethra, making it difficult to evacuate their bladder completely. So that's why, Grandpa's getting up every 10 minutes to go to the bathroom, because Grandpa goes to the bathroom and not much comes out. Yeah. Questions on this material?
Yeah, what's in the upper right? That column.
This is the nephron. So the nephron is the functional unit. So these are
It looks
all
different.
across. Yeah, it's a crappy drawing. Yeah. So in your cortex, there's literally thousands and thousands of these, right? So as we talked about in lecture today, your kidneys are filtering somewhere on the order of 180 liters a day. So your kidneys are literally filtering gallons of blood every single day. Okay. Let's talk real quick about dialysis. Okay. So if your kidneys don't work, you have to go to dialysis, and dialysis is filtration. Okay. So as we talked about, you selectively reabsorb most things. Okay. So what do I need to do in dialysis? I need to only filtrate out the stuff I want to get rid of, like glucose and nitrogenous waste and all of that. Okay. So you got this giant machine. Okay. And you got a tube here, okay? And the tube is permeable, and you got solution on either side, okay? So if I don't want to, if I want to excrete out glucose, guess what I'm going to put in the solution? I'm going to put glucose into the solution. So what will happen then? How does filtration work, guys? By gradients, right? Diffusion, simple diffusion, right? So if I don't want to get rid of glucose, if I want to get rid of glucose, I put glucose in the solution. Why? So then the glucose from my blood won't diffuse into the surrounding solution. Okay? So I put in the solution the stuff that I don't want to excrete out. Does this make sense? Does everybody understand that concept, right? So dialysis is really, really complicated, guys. So each time you go in for dialysis, they're going to analyze you and see what's going on in you, and then they are going to custom design, set up your dialysis machine with a custom, basically, recipe specifically for you, so that we filter out the stuff that needs to get filtered out, and we don't filter out the things we want to keep, like proteins and other, nitrogens and other kinds of things like that, right? So dialysis is really complicated, guys, and so each time you go in for dialysis, right, they're gonna draw your blood, they're gonna analyze it, and then they're going to, back in the old days, it was literally, they were adding chemicals. Now it's computers that do it all for them, and then you just sit there, right? So if you're on full-time dialysis, they're gonna put a PICC line in you. You just sit there and it just runs your blood through the machine, and it takes a couple hours. And you got to do that a couple times a week. Like you can only go like if you get it done on Monday, like you got to go back on Wednesday to get it done. And if you really want to be good, you got to get it done pretty much every single day. Have you ever been to a dialysis clinic before? Yeah. So it is extremely complicated stuff, guys.
I had a guy that I bought a car from across town, and he was doing in-home dialysis.
Yeah.
Like he was on a kidney transplant.
Yep. Yeah. So if your kidney's bad enough, yeah, and if you got good enough insurance, they'll actually put it in home. But even then, you still got to have a nurse who specializes in dialysis come in every day and calculate it every day, because it might be different from day to day. Right? So even if you got in-home dialysis, you got a dialysis tech, a nurse coming in, and they're recalibrating it every single day to make sure that we filtrate out what we need to filtrate out and reabsorb what we need to reabsorb, and then put it back in your blood. Yeah.
Oh, no, I was just.
Yeah. Any questions on any of this stuff, guys? No? Have yourselves a good weekend. Everybody say bye to Carmen.